Hello friends, welcome to Projectile Academy. In this particular lecture, we will discuss about the projectile motion. So let's begin. So what is a projectile? A projectile is an object that is thrown into the space such that the only acting force on that projectile is due to the center of gravity. Okay, so there is no force along the horizontal direction. So what is a projectile? A projectile is an object that is thrown into the space at an angle alpha. Suppose the initial velocity is u, so it is thrown at an angle of alpha. The only force that is acting on the projectile is due to the center of gravity. Okay, so Fy will be mg. The force due to center of gravity is in the negative y direction, and in the horizontal direction there is no force. Okay, there is no force on the projectile, so Fx is equal to 0. So this means this is equal to m d2x upon dt square is equal to 0. So there is no force in the horizontal direction, but in the vertical direction we have the force that is due to the center of gravity. So m d2y upon dt square, by the Newton's second law of motion, m d2y upon dt square is equal to minus mg. Okay, so we have the equation of motion as m d2x upon dt square is equal to 0 and m d2y upon dt square is equal to minus mg. Okay, so we will use, these are the two most important equation of motion that are based on the Newton's second law. Okay, so let us move further. Okay, so what we are going to study in this topic of the projectile motion is, okay, what is a projectile? Okay, we will discuss about the trajectory, latus rectum, vertex, okay, the vertex of the projectile, focus and the directrix of the trajectory, what will be the time of flight in this motion of the projectile, horizontal range, maximum height, velocity at any point of the trajectory. Okay, suppose we take any random point, so what will be the velocity? Okay, now locus of the focus and vertex of the trajectory, some geometrical properties of the parabola. So this is all about the projectile. So let us start our discussion. Okay, so let us proceed with this. So a projectile is any object thrown into the space upon which the only acting force is the gravity. Okay, so this we have already discussed. While the during the motion of the projectile, there is the only acting force that is acting on this is due to the center of gravity. So this we have already studied. So the only acting force is this due to the center of gravity, that is in negative y direction, that is minus mg. But in the horizontal direction there is no force. Okay, so this is coming from the Newton's second law of the motion. Okay, so now we have this when a particle is thrown obliquely is means at an angle, okay, near the earth's surface, it moves along a curved path under the constant acceleration. So the acceleration is due to the center of gravity, this is constant acceleration. Okay, the path followed is called the trajectory. Okay, so this path that is followed is known as the this path that is being followed is trajectory. Okay, and there is no force along the horizontal direction, the only force is due to the center of gravity, that is mg. Okay, so the horizontal motion is due to horizontal motion is due to uniform velocity. Okay, और दूसरा vertical motion is uniformly accelerated. Okay, because there is no change in the velocity, so the velocity is uniform. The velocity here is constant in the x direction at all the points. Suppose let us take few points and understand this in detail. So let us consider this projectile. Okay, so let us take few points here. Okay, so at all these points the horizontal velocity is constant, this is u cos alpha. At all these points, horizontal velocity is u cos alpha. At all these points, horizontal velocity is u cos alpha. But the velocity along the vertical direction is not constant. It is getting changed. So suppose this point is 1, this is 2, this is 3. So we have this as Vy1, this is Vy2, this is Vy3. Okay, so the velocity along the vertical direction is getting changed. Okay, with the passage of time. Okay, so we have considered 3 points. At all these 3 points, we have the horizontal velocity is constant, that is u cos alpha, u cos alpha. Okay, but the velocity in the vertical direction is getting changed. Okay, so let us proceed. And this, the motion that is in horizontal one is due to the uniform velocity, but in the and acceleration is 0 here, because there is no change in the velocity in the horizontal direction. Okay, but in case of the vertical motion, it is a uniformly accelerated motion, and acceleration is not 0, because velocity is getting changed. The change in velocity is due to the acceleration. Acceleration is the change in velocity. The velocity is getting changed, so we can say that the motion is uniformly accelerated motion. Okay, so let us proceed further. Okay, so we have this motion as, let us consider this as 1 and this as 2. Okay, so let us expand this. So m d2x upon dt square is equal to 0. So let us integrate this with respect to t. So we have dx upon dt is equal to constant. Okay, so let us consider this as, this is the velocity along horizontal direction, so vx. This is constant. So we have studied a couple of minutes ago is that the velocity in the horizontal direction is constant at all the points. This is equal to u cos alpha. So this is constant throughout the motion. So we have this is equal to u cos alpha, because the initial velocity is u and we have resolved in the x and y direction. So resolving u in the x direction is u cos alpha, and if we resolve this in the y direction is u sin alpha. Okay, so the horizontal velocity is constant is equal to u cos alpha throughout the motion. Okay, so we have Vx is equal to u cos alpha. Okay, so let us calculate Vy. So let us take equation 2. So we have this as m d2y upon dt square is equal to minus mg. So this gets cancelled. So let us integrate this with respect to t. We have dy upon dt is equal to minus gt. So we have this is velocity Vy. So velocity at random point. Okay, so this will be, sorry, on integrating this we have a constant of integration also. Okay, so at t is equal to 0, we have Vy is equal to, what is Vy? This is u sin alpha. Vy initial is equal to u sin alpha. So u sin alpha. So let us put u sin alpha at t is equal to 0. So u sin alpha is equal to, put t is equal to 0 here, so this is 0 plus a. So value of a is u sin alpha. Okay, so this equation becomes Vy is equal to u sin alpha minus gt. Okay, so this is Vy is equal to u sin alpha minus gt. Okay, so let us draw this for the better understanding. So we have at any random point, let us take the random point. Okay, and let us analyze the velocity there. So let us take a random point here. Okay, pxy. Okay, so what we have studied is that the velocity along the horizontal direction is always constant. So this is equal to, velocity along the horizontal direction is constant throughout the motion. So this is u cos alpha. And at time t, we have the velocity along the vertical direction is this one, u sin alpha minus gt. Vy is equal to, so the net velocity v is equal to vx square plus vy square का under root. So this is Vx is equal to, okay, so the net velocity V is equal to u cos alpha whole square plus u sin alpha minus gt का whole square का under root. Okay, so this is the velocity along the horizontal direction. So what will be the angle if we draw the tangent at any particular point, tangent at that point? So this is, let us consider this as psi. So tan of psi is equal to Vy upon Vx. This is equal to u sin alpha minus gt upon u cos alpha. This is the angle made by the tangent with the horizontal. Okay, so let us proceed further towards the calculation of x and y coordinate at a random point. So now we have this, let us consider a point, random point pxy. Okay, pxy. So let us find the x coordinate and the y coordinate. So this total distance is x and the velocity along the horizontal direction is u cos alpha. Okay, so x is equal to velocity into time, so u cos alpha into t. Okay, x cos alpha into t. Okay, and now let us find y. So how we can find y? So we have the, from the equation of motion we have s is equal to ut plus half at square. Okay, so we are taking a, we are analyzing in the y direction. Okay, so we have y is equal to initial velocity along the y direction, so uy into t and minus half of, this is at square. Okay, minus half gt square. Okay, so y is equal to, the initial velocity is u sin alpha. Okay, so u sin alpha into t minus half of gt square. So at any random point we have, this is u cos alpha into t, or this is u sin alpha t minus half gt square. Okay, so this is the random point, coordinate of the random point after passage of time t if the initial velocity is u and it is thrown at an angle of alpha. Okay, so let us move further for determining the equation of trajectory. So equation of the trajectory is a parabola. Let us show this. The equation of trajectory, trajectory is the path followed by the projectile. Trajectory is parabola. Okay, so let us see some basics about the parabola. Okay, so we have this. Okay, so this is our parabola. So we have focus here at a distance of, sorry, okay, so this is x-axis, this is y-axis. Okay, so we have focus at, this is origin, so this is a comma 0. Okay, so this is our focus, S, focus. This is our vertex of the projectile, sorry, vertex of the parabola. We are not considering projectile right now. Okay, so this is vertex, this point is the vertex, and at a distance of a from the y-axis we have the directrix. This is our directrix. So this equation is x is equal to minus a, and if you draw the vertical line through, passing through the focus, that is parallel to the y-axis, so this is the latus rectum, Okay, so this equation is x is equal to a, and this whole distance is the latus rectum. Okay, so this whole distance is 4a. Okay, how we can find this distance? So we have the property of the lattice, we have the property of the parabola is that, suppose we take a random point p x y, so its distance from the focus is equal to the distance from the directrix. So this distance is equal to this distance. Okay, so this is p, so this is ps, this is m, so we have ps is equal to pm. Okay, so distance of this point from the focus is equal to distance of this point from the directrix. So similar way, so distance of this point from the focus is a, sorry, the distance of this point from the focus is equal to distance of this point from the directrix. So this distance is a, this distance is a, this distance is a, so his whole distance is 2a. Okay, so this distance will be 2a. So let us name this as AB, A, B and S. So we have this as A dash, okay, and this as B dash. So this is also 2a. Okay, so we have AA dash. AA dash is equal to 2a is equal to this distance. This is AS. So this will be 2a. This whole distance will be 2a. Now find this distance. So this distance is equal to 2a. BB dash is equal to 2a is equal to this distance. This is BS. Okay, so this is also 2a. So this is 2a and this is 2a. So this whole distance is 4a. Okay, so this is the basics of the parabola. Okay, so what we have, the basic concept of the parabola is that the distance of this point from the directrix is equal to distance of this point from the focus. Okay, and this is our latus rectum. Okay, so the trajectory, equation of trajectory is a parabola. I will show you that how this parabola is coming. The equation of trajectory is parabola. Let us prove this. So this is all about the basics of the parabola. Now let us understand few concepts about the shifting of origin. Okay, so if you are aware about the basics of the parabola, the equation like this. This is a parabola. Let us take this equation as x square is equal to 4ay. Okay, so if we take the image of this parabola in this x-axis, so we have this as this one, x square is equal to minus 4ay. Okay, so if we shift this parabola to a vertex, so here the vertex is origin. Okay, if we shift this vertex to, let us draw this, let us rub this. This is x square is equal to minus 4ay. Okay, so this was our x square is equal to 4ay. So we have taken the image. So for if we take the image, then we replace y with minus y. So this is x square is equal to minus 4ay. Okay, so let us rub this. Okay, so here the vertex is 0, 0. So here we are shifting this origin to a point ph, k. So what will be our equation? So let us consider the equation as x square is equal to minus 4a into capital Y. Okay, so we have capital X plus h is equal to small x and capital Y plus k is equal to small k. So from here we have x is equal to x minus h and capital Y is equal to y, this is y, so y minus k. So the equation will be, so this equation will become, so this equation will be x minus h whole square is equal to minus 4a y minus k. Okay, so this is the equation of the parabola. If we consider this h and k as the vertex instead of this origin. So if we are taking this as origin, then we have this as x square is equal to minus 4ay. So now we have shifted this origin to a point p h k. Then the equation of parabola is x minus h square is equal to minus 4a y minus k. So let us show this, that equation of trajectory is a parabola. Okay, so trajectory is the path followed by the projectile. So the path followed by the parabola is, sorry, the path followed by the projectile is parabola, that we have to show here. Okay, so let us show this. Okay, so we have the coordinate as x is equal to u cos alpha into t, and y is equal to u sin alpha into t minus half gt square. Okay, so from here we have t is equal to x upon u cos alpha. Let us put there here. The y is equal to u sin alpha into x upon u cos alpha minus half gt square, g into x upon u cos alpha का whole square. So this is equal to y is equal to u tan alpha, sorry, x tan alpha minus half gx square upon u square cos square alpha. Okay, so let us take this here in the left hand side. So we have gx square upon 2u square cos square alpha, okay, minus x tan alpha is equal to minus of y. Okay, so let us multiply this with 2u square cos square alpha. We have x square minus 2u square cos square alpha upon g into x into sin alpha upon cos alpha is equal to minus of 2u square cos square alpha upon g into y. Okay, so we have multiplied throughout by g upon 2u square cos square alpha. So here we have 2u square cos alpha, this gets cancelled, and this is okay. So this will be x square minus minus u square upon g 2 sin alpha cos alpha. Okay, 2 sin alpha cos alpha into x is equal to minus 2 upon g u square cos square alpha into y. Okay, so this we are having this as x square minus u square upon g sin 2 alpha into x is equal to minus 2 upon g u cos alpha का whole square into y. Let us further simplify this. So we have this as x square minus, let us put 2 here. So minus 2u square upon 2u square sin 2 alpha. This will be sin 2 alpha. 2 sin alpha cos alpha is sin 2 alpha. So u is 2u square upon g sin 2 alpha. Sin 2 alpha upon, let us put 2g here. Okay. So 2 into u square sin 2 alpha upon 2g into x. So 2ab we have to find in this form x minus h का whole square. Okay. So we will add u square sin 2 alpha upon 2g का whole square. Okay, and subtract this minus u square sin 2 alpha upon 2g का whole square. Okay, is equal to minus 2 upon g u square cos square alpha into y. Okay, so this will be the, so let us take this as x minus u square sin 2 alpha upon 2g का whole square. Okay, is equal to, let us take this into right hand side. So you have u square sin 2 alpha upon 2g का whole square minus 2 upon g u square cos square alpha into y. So this is equal to, this we can write that 2 sin alpha cos alpha. So this is 2 sin alpha cos alpha. Okay, so this is equal to x minus u square sin 2 alpha upon 2g का whole square is equal to 4u4 sin square alpha cos square alpha upon 4g square minus 2 upon g u square cos square alpha into y. So this gets cancelled. Okay. So we will have here as, let us take this out. So this is minus 2 upon g u square cos square alpha into y minus u square sin square alpha upon 2g. Okay, so this is equal to x minus u square sin 2 alpha upon 2g ka whole square. So let us compare this with x minus h ka whole square is equal to minus 4a y minus k ka whole square. Okay, on comparing this, we have x is equal to, sorry, h is equal to, so our vertex is, vertex of the parabola is, we have the vertex of parabola as ph comma k. Okay, so the vertex as h is equal to u square sin 2 alpha upon 2g, or k is equal to u square sin square alpha upon 2g. Okay, so this is as the vertex of the motion of the projectile. So this motion is, this equation is basically a equation of projectile. Sorry, let us repeat this. So this equation is a equation of a parabola. Equation of parabola. Okay, this equation is the equation of parabola. Hence, trajectory of projectile is a parabolic one. Okay, so this equation is parabolic. Let us proceed further. Let us find the latus rectum, vertex, focus and the directrix of the trajectory. Okay. Latus rectum. Okay, so what is in the projectile? The latus rectum is passing through the focus. So this is our focus. So this is our latus rectum. Okay, so this is a comma 0 is our focus, and directrix is at a distance of a from the vertex. So this is our vertex. Okay, so this is our directrix. Okay, so this whole distance is 4a. Okay, so what we have seen, the equation of trajectory is y is equal to x tan alpha minus gx square upon 2u square cos square alpha. Okay, and this can be further written as x minus u square sin 2 alpha upon 2g whole square minus is equal to minus 2 upon g into u square cos square alpha into y minus k. The value of k is u square sin square alpha upon 2g. Okay, so this is, so this, let us compare this with x minus h whole square, standard equation of the parabola, minus 4a into y minus k. So this is our, this value is 4a. Okay, so the latus rectum is equal to 4a is equal to 2 upon g u square cos square alpha. Okay, so this can be written as 2 upon g into horizontal velocity ka whole square, latus rectum. Okay, so the latus rectum is 2 upon g into horizontal velocity. So this is our latus rectum. Okay, so this is our focus and this line is the latus rectum. The distance is 4a. Okay, so this is directrix. So let us take some point here. So distance of a point from the focus is equal to distance from the directrix. So this point is, let us take this as point P. So PM is equal to PS. So PM is equal to PS. Okay, so this directrix is at a distance of A from the vertex. Okay, so this distance is also A. Okay, so this S is at a distance of A from the vertex, and directrix at a distance of A from the this vertex. Okay. Now let us find the horizontal range. What is our range? How we can find this? What is range? So in case of a projectile, okay, so this distance is range. Okay, so let us resolve the initial velocity u. So this is angle is alpha. So this is u cos alpha, and this is u sin alpha. At this point we have x is equal to u cos alpha into t and y is equal to 0. So let us write down the trajectory. So trajectory is equal to y is equal to x tan alpha minus gx square upon 2u square cos square alpha. 2u square cos square alpha. So we have this as, let us put at this particular point we have y is equal to 0. So let us put this as 0. So y is equal to x of tan alpha minus gx upon 2u square cos square alpha. Okay, so we have this as x is not equal to 0. So we have this as tan alpha is equal to, this term will be 0. So tan alpha is equal to gx upon 2u square cos square alpha. So x is equal to tan alpha, we can write sin alpha upon cos alpha into 2u square cos square alpha upon g. Okay, so this gets cancelled. So this is equal to 2u square upon g, u square upon g into 2 sin alpha cos alpha. X is equal to, x is equal to u square upon g into sin 2 alpha. So this is our range. So the horizontal range is equal to u square sin 2 alpha upon g. Okay, so this is also evident from the vertex. So vertex we are having u square sin 2 alpha upon 2g and u square sin square alpha upon 2g. So this is half of range. So this is r by 2 and this is by symmetry. This is half of range. So r by 2 is equal to u square sin 2 alpha upon 2g. So r will be this value. So this is range. Okay, also what we have to find? Maximum height. Okay, how we can find the maximum height? Obviously, the y coordinate of the vertex will be the maximum height. Okay, so the vertex is equal to maximum height is equal to y coordinate of vertex. ठीक है, तो y coordinate of vertex is this. So maximum height is equal to u square sin square alpha upon 2g is the maximum height.